Okay, hi guys, welcome back to Think Tank Online Learning. So in this video, I want to find the center of mass of a solid. So the density in this question is 2, and are given a solid that is bounded by x squared plus y squared equals to 4. And you should know that this is the equation of a cylinder. Okay, and then the plane z equals to 0. Okay, above a paraboloid, z equals to 4 minus x squared minus y squared. Okay, so what we're going to use, we know that from physics, we know that density is equals to mass over volume. So if you want to find mass, we're going to say mass equals to density times volume. Okay, so that is what we're going to do. Okay, so I'm going to use cylindrical coordinates. So if you're not familiar with cylindrical coordinates, I have got a video, a 1-hour video that explains how to use spherical and cylindrical coordinates. So I think you should watch that. Okay, but what I'm going to do here is that we have a circle here, we have a circle here. So if you see, if you solve this equation simultaneously, you're going to obtain this equation. So let me just draw a circle here just for reference. Okay, so this is the circle, just going to use y, x. Okay, so this is the region we want. Okay, so that means theta, the angle rotates right around the z-axis, ranges from 0 to 2 pi. Okay, then r, which is the radius, from 0 to 2. Okay, the reason why I'm writing this is that this question needs a lot of space. Okay, so that's why I'm trying to squeeze things so that everything will fit here. Okay, so what we're going to do, I want to find, we said mass is equals to the triple integral of density times volume. Okay, and I said the dv is just a function that represents for dy, dx, dz. Okay, and what do we know that? We know that in spherical coordinates. Okay, look, let's say if you have no idea, maybe to give you just a clue, you have x squared plus y squared equals to 4. Okay, and you've got the same thing here. Okay, so now I want to find the upper bound of z and lower bound of z. Okay, so if z equals to 0 and this one, so if you just choose, think of a number, let's think of 1. We have z equals to 0 here, and we have 4 here. Okay, we have 4 minus 2, 4 minus 2, that is equals to 2. So this one is the upper bound. So for z, the lower bound is 0, the upper bound is 4 minus x squared minus y squared. But we know that x squared plus y squared is equals to r squared. So that means z ranges from 0 to 4 minus r squared. Okay, cylindrical coordinates, we just make our work easier. Okay, so now let's find the mass first. Okay, so 0 to 2 pi for theta, 0 to 2 for the radius. Okay, and we have for z 0 to 4 minus r squared, and we're going to have dz for dy dx is r dr d theta. Okay, now if we integrate with respect to z from 0 to 2 pi, 0 to 2, we're going to have z, our bound, 0 to 4 minus r squared, and we have r dr d theta. This r is very important, should not forget it. Okay, but we have the density, so let me just put 3 here. Okay, it's 2, so the density is 2. I'm going to put 2 here. Okay, and what I'm going to give, the mass is going to be 2, 0 to 2 pi, 0 to 2 for the radius, upper bound minus lower bound. So we're going to have 4 minus r squared times this r dr d theta. Okay, and we're going to have 2, 0 to 2 pi, 0 to 2, and we're going to have 4r minus r cubed. Okay, dr d theta. I think now it's time to integrate with respect to r. We're going to have 2, 0 to 2 pi, and we're going to have r squared over 2 minus r to the power 4 over 4. Our limits from 0 to 2 d theta. Okay, and we're going to have mass. The mass is from 0. The mass is 2 times the integral 0 to 2 pi. Okay, what happens if say upper bound minus lower bound here? Okay, so you know that 2 into 2 into 4 is going to be 2. Okay, so we're going to get here is 2 times 2 times 2, so I'm going to have 8 minus, okay, so it's r to the power 4 divided by 4, so this is going to 2 to the power 4, it's 16 divided by 4, going to have 4 the theta, okay, and if we do that, we're going to get 0 to 2 pi of 4 the theta. Now it's time we integrate respect to theta. We're going to have 4 theta 0 to 2 pi for the limits, okay, and if we say upper bound minus lower bound, what we're going to get, we're going to get 16 pi. So 16 pi is the volume, okay. So now I want to find the center of mass, okay. So I'm going to show you what the working pattern. Just remember that when I given a cylinder and we have your z coordinate is 0, your lower z coordinate, okay, like given a cylinder, just know that the x coordinate and the z coordinate are going to be 0. You only need to find the z coordinate for center of mass, but I'm going to show you how, okay. Okay, so the center of mass, how we're going to calculate the center of mass, okay, so for x, okay, then just call it x bar, which is the coordinate of x for center of mass. We're going to say, first of all, we have to calculate myx over the mass. Then for y bar, it's mxz over the mass. Then for z bar, we'll say myx over the mass. Okay, I know it's a bit of a long process, so first of all, I'm going to start with x. Okay, so let's say you are given a variable, let's say your density varies, let's say x, okay, can't figure out x, okay, just put it inside. Okay, so for x, we said x, I'm going to say myx, okay, it's not myz, okay, since you don't need x here, okay, so it's myz, okay. So for myz, okay, this is z, in case you're not seeing, okay. So I'm going to say, going to repeat the process again, the triple integral, okay, v, and we have the x, we're going to put x here, times density, okay, dv, okay. So we already evaluated our limits, okay. So 0 to 2 pi for the angle, 0 to 2 for the radius, and for z 0 to 4 minus r squared. And we know that what is x in polar coordinates? X equals to r cos theta, that means y equals to r sine theta. Okay, so I'm going to have r cos theta and dz r dr the theta, okay. So if we simplify, you're going to get 0 to 2 pi, 0 to 2, 0 to 4 minus r squared. Let's say r times r, we're going to get r squared cos theta, okay, dr d theta. Okay, now let's integrate now with respect to z. When I get in respect to z, so if we integrate with respect to z, what are we going to get if we integrate with respect to z? We're going to have 0 to 2 pi, 0 to 2, okay, and we have r squared cos theta times z, lower and upper bound for z is 0, 4 minus r squared dr the theta, okay. So that means I should have put dz here, okay, we have dz here, okay. And now if say upper bound minus lower bound, see our lower bound is 0, so everything will go to 0. So we're going to have z, okay, but we have this density, okay, density is what? Is 2. So if we put density, since it's a constant, we have 2. Okay, so I'm going to have 2, 0 to 2 pi, 0 to 2. So we're going to have the upper bound for z is going to be r squared cos theta times 4 minus r squared, and we're going to have dr d theta, okay. And what are we going to get next? Okay, 2 for the density, 0 to 2 pi, and we're going to have 0 to 2, okay. So we're going to have r squared cos theta times 4 minus r to the power 4 cos theta dr d theta. Now let's integrate with respect to r. Okay, so if we integrate with respect to r, what are we going to get? We're going to get 4r to the power 3 divided by 3 cos theta minus, okay, so what we're going to get, r to the power 5 over 5 cos theta, limits for r 0 to 2, and I'm going to have the theta for the angle, okay, and we know that, okay, I think we need to continue here, okay, so we're going to have 0, 2 to 2 pi, so 2 to the power 3, that will give us 16, okay, that will give us 8. 8 times 4 is now 32 over 3 cos theta minus, and 2 to the power 5, that is 32, minus 32 over 5 cos theta, and we have the theta. Okay, so let's integrate with respect to theta. If we integrate cos theta, we're going to get sine theta. Okay, so we're going to have 2 sine theta over 3 times 32 minus 32 over 5 sine theta from 0 to 2 pi. Okay, and you know that sine theta, sine 2 pi is equals to 0 and sine 0 equals to 0, so we're going to have 0. Okay, since I said we have a lower bound z, so this thing lies on the z, lies on the z-axis, so by symmetry we can conclude that if myz is equal to 0, okay, that also means mx, anyway, that is not our case. Okay, now I want to find z. Okay, so for z it's now m, for z it's now myx. Okay, so just the same, triple integral of v, and we have z times the density, okay, z times the density, and we're going to have dv. We've already calculated the limits 0 to 2 pi, 0 to 2, and 0 to 4 minus r squared. And please don't change this z into polar coordinates before integrating it. Okay, you get a different wrong answer. Okay, remember the first one calculated follow, just say upper bound minus lower bound, didn't have z, we have nothing, we had nothing here. So in this case we have z times density, which is equals to 2. So I'm going to say dz dr d theta. Okay, so I'm going to put r, because it's r dr d theta. Okay, now let's integrate with respect to z, 0 to 2 pi. Okay, 0 to 2, we're going to have z squared over 2, our limit 0, 4 minus r squared, and we have dr the theta. Okay, now 0 to 2 pi, 0 to 2, if you plug in our limits, we're going to get 4 minus r squared to the power 2, or divided by 2 times r. Okay, dr the theta. Okay, so it's 0 to 2 pi, 0 to 2. Okay, so if you simplify, you're going to get 4 squared, that is 16, divided by 2, that is 8 times r. So I'm going to have 8r, and I'm going to have 4 times negative r squared, negative 4r squared times 2, negative 8r squared, times this one. Okay, so that is negative r to the power 3 divided by 2, so it's negative 4r to the power 3. Okay, and here r squared times r squared is r cubed times r, so we're going to have r squared times r squared is r to the power 4 times r, so we're going to have plus r to the power 5 divided by 2, and we have dr the theta. Okay, now so if we integrate, we said 2 for the density, same here, 2 for the density. So if we integrate with respect, let's just integrate with respect to r. Okay, we're going to have 8r squared minus 4r to to the power 4 over 4 plus r to the power 6 over 12 d theta. Okay, then the limit for r is from 0 to 2. Okay, so what are we going to get? 0 to 2 pi. Okay, so I think here it's clear. Okay, but remember, when integrated with respect to r, we should have written divided by 2. Okay, so now this one in this one we get 1, this one in this one we're going to get 4. Okay, so if we say r squared, which is 4, times, we're going to get 16 minus r to the power 4, we're going to have negative 16. What about here? We're going to have 2 to the power 6. I think that is 64. Okay, 2 to the power 6, that is 64, divided by 12 the theta. Okay, it's 64 divided by 12. Okay, and you're going to have 0. So if we integrate with respect to theta, you're going to have 2. Okay, 64 over 12 times 2 times theta. Okay, 0 to 2 pi. Okay, and we're going to have 64 over 12. Okay, times 2 pi. Okay, and what is going to be the answer? 4 over 3. Okay, so this is, we got this one here, and we have this one here. Okay, now to find the coordinate for the center of mass, it's now is we're going to use this formula. Okay, so since I'm running out of space, I think you can just allow me to perform for x bar here. So x bar equals to 0 over the volume, which is 16 pi, and that is equal to 0. Okay, then for y bar, we're going to get 0 divided by 16 pi, and this is equal to 0. Now for z bar, okay, for z you're going to have 64 over 3, and remember I've got pi here. Okay, got in pi here. Okay, so you have 64 pi over 3 divided by 16 pi, and what is going to be our answer? Okay, so if we say 64 remainder 3 divided by 16, okay, we're going to get 4 over 3. Okay, so we're going to get 4 over 3. So I'm going to write the coordinates for the center of mass here. We have 0, 0, 4 over 3. Okay, so these are the coordinates for the center of mass. Okay, so thank you for watching. Don't forget to subscribe, support my work by subscribing and liking. Okay.